Hello everyone, welcome back to my channel. My name is Piyush and this is video number 20 in the series CK 2024. This is a prerequisite of our next video which is going to be about certificates in Kubernetes. So before going into that, I wanted to discuss about how SSL TLS actually works, and if you are already aware about that topic, feel free to skip that video. But in this video, we'll be doing a deep dive into SSL TLS and how it works end to end. So we'll be doing that, and the comments and like targets of this video will be 120 likes and 120 comments. It's small target and I'm sure you can do that. So without any further ado, let's start with the video. Alright, so let's take a simple example first and then we'll go deep into that. So let's say you have a user who is trying to send a request to a server. Okay, so I'm just gonna create a user over here. That's your user, and let's create a server as well. So this server could be a web server, this server could be an application server, anything. For now, just we are just taking an example of how a user communicates with a server over the internet. And this user could be not just user, this user could be a client. So it's a client and server interaction because everything is an interaction between a client. So when we are sending the request, we become a client, and then where we are sending the request and from where we are expecting the response, that's actually a server. So that could be over here, right? So let's say we are a user. Okay, so we will send a request to this server. Okay, maybe this could be, let's say, a get request. So there are different type of HTTP requests such as get, put, post, and so on, right? So for now, this user is trying to get some data from the server, so that is why it is sending a get request, and this is over HTTP protocol, right? So this is over HTTP protocol, hypertext transfer protocol. So everything over the internet either goes through HTTP or HTTPS. If we are accessing a web browser, a web client, so it has to go through a HTTP connection. We'll talk about HTTPS later on, but first let's have a look at how HTTP actually worked before. So a user sent the request, but then server asked the authentication details of the user, right? So server said, okay, I've got your request, but first identify who you are, right? So identification. Then user sends the credentials to the server. Okay, so here's my username, here's my password. Okay, so then user sends the credential. But okay, let's say after that server authenticate the request and then it actually provided the requested details. And authentication is nothing but you are defining who you actually are. That's the part of authentication, right? So when user provided the credential like its username and password, server authenticated it and sends the response back. But there could be someone else in the middle, right? So this there could be a hacker who is sniffing the network and who is also looking into any unsecured connection request and response. And as soon as he finds out that someone is sending their credential over the internet, that hacker sniffs that request. And now this hacker has all the credentials, all the details, and now this hacker can actually send the request to the server and it gets the response from your server. So you have been hacked, right? And this is okay, like if you are just browsing a site with just the informatory site, like a static page which does not have any details, no login, no authentication whatsoever. But what if it was a highly confidential website, like your banking website, your stock trading brokerage website, your insurance website, and so on? There could be thousands and thousands of websites for which this hacker can sniff the data from, and it could make it really worse, right? So like our HTTP is not considered as secure, because of these many reasons, and there'll be a lot more. So what we have discussed now, what if a way to actually send this message, like after the identification is done, your user is sending your identification details. What if there was a way to actually encrypt this data before sending it to the server, right? So we need something called a key, right? A key or a token to actually encrypt this. To do that, you actually added a key, right? And you use this key for encrypting your data, which is your identification details, let's say, or any data afterwards. But now this key was generated at by the user. It's at the user end, and this key has to be sent to the server as well to decrypt the data. Okay, so this data over here, it has to be sent from user to the server, right? And we are saying that encrypt this data with the key. Okay, so let's say user encrypt this, and he sends the data to the server receives it. Now this is in encrypted format. How would server know that what exactly is there in the data, because it is encrypted? So server would need a key, and this key, again, we have to send this key from user to the server. So now that server has the key, server can actually decrypt the data using the same key. So this type of encryption is called symmetric encryption. In symmetric encryption, the same key is used to encrypt and decrypt the data, right? But it has a loophole. You see, when you are transferring your data over the internet, so let's say first you transferred your identification, which is your data. So again, this hacker can get hold of this data, right? So he gets a copy of this identification. Now this data has been transferred to the server. Now when you were sending the key, because server needs a key to decrypt this data, when you were sending the key, again hacker got a hold of it, and he would then get a copy of the key. So your server receives the key, your server would be able to decrypt the data from the key provided, but then hacker also has your data and your key, so he can also do the same, and you have been compromised over here. So that is why symmetric encryption is not considered one of the best practice, especially when we are transferring data over the internet. So what options do we have? Let's have a look at another example. So here's a user, here's a server. Okay, I'm just gonna drag it down over here. Okay, let's say a user has a key, the same symmetric key. Now let's say you have a user and then you have a server, and you are trying to create a secure connection to the server. You have to, let's say, log into the server. So you want to create an SSH connection to the server. So because password are too risky, it can be compromised and others can easily get access to your password. So you have decided to create a connection with the help of a key. So for that, what you will do, you will create a public and private key pair. So let's call this a pub key. That's your pub key, and that's going to be your private key. So how do you do that? Actually, there is a utility. So it's called SSH keygen. So using this utility, you generate these two keys. Okay. So there is a pub key and a private key. Why we are creating two keys? So that we can use one key for encryption, another key for decryption. Because we have seen some disadvantages of using symmetric encryption. So that's why we decided to use asymmetric encryption. So in this case, where we are using a separate key for encryption and a separate key for decryption, so this type of encryption is called asymmetric encryption. Okay. So earlier it was symmetric encryption, now it is asymmetric encryption. Now, you have your public and private key. What you will do, you have to create a connection with the server. Okay, now you have your public and private key generated. Now, what you will do is you will keep your private key with yourself because this is used for encryption, and the public key is publicly available. So you will send this public key to your server. Right, so this public key will be added to the, if you have ever set up the SSH authentication. So there is a file inside the server which is called .ssh authorized keys, right? So you would add this key as an entry to this file. Now the public key is securely placed on the server. Now private key, as I've said, because this is private, this is something that you would use for encryption, it will retain with you. So you will send a request to the server like an SSH request, and you will pass the private key along with the SSH request and its sort of credentials, and it will be transferred to the server. Server verifies it, and server decrypt the data with the help of public key, and it will send the response back. So that's how your SSH connection will be established. Now let's have a look how this will work in case of a connection over the internet. So we'll take the same example, but instead of doing the SSH connection, we'll create an HTTP connection. Okay, over here user will be sending an HTTP request to the server. Okay, that's your HTTP GET request, let's say. Okay, and in return server will return a public key. So server will have two key over here. So it will have server public key, and let's call it server private key. Okay, so we have a server public key and server private key. Let's copy the key icon as well. Is the key. Okay, and let's copy one more time. Okay, so now this server has two keys, a server pub key and a server private key. And how those keys were generated? So there was a utility. So there is a utility and it's called OpenSSL. So we generate certificates and keys from this utility, right? So that's how they have been created on the server itself. So now the private key, because it is private and it has the decryption details, so we will be using this key for the decryption. So that's why this key will be retained by the server itself, right? So server will have the private key and the public key will be used for the encryption of data. That's why this key will be sent to the user. Okay, so now user has server's public key. Okay, I'm sure it is making sense till here, but you can repeat the previous one if you are still confused. Okay, so I'll just give a quick recap. So over here, our server generated a key pair, a public and private key pair from the OpenSSL utility. Private key has to be retained with the server, and public key it will send after the GET request. It will send the public key to the user. Now, what user will do with this public key? User also have a key, and it's called a symmetric key. Server uses a asymmetric key pair, public and private, but user will have one symmetric key. So let's call it user sim key. Okay, so now what user will do, now user will encrypt this symmetric key with public key, right? So the user will use the public key, the server's public key, to encrypt the user symmetric key. Because earlier what we were seeing, the challenge that we were seeing over here, when we were sending the private key from the user to the server, there was a chance of getting that hacked by the hacker. So hacker would get the credentials, would get the private key, and it will encrypt or decrypt the data because we were using the same key. Or when we were using the public and private key pair, both the keys has to be sent to the server. So again, hacker can get both the keys, public and private key. So that's why we are using this technique over here, where we are using a public private key on the server and one symmetric key on the user. Now user will get the public key. User will use that public key to actually encrypt the symmetric key of the user. So this is encryption. Okay, now we put that all together. Okay, and I'm just gonna group them together. Okay, so I've grouped them together. Now this part, okay, what does it have? It has the data, it has the encrypted symmetric key, because our main goal was to transfer the symmetric key from user to the server securely. So now this key will be transferred over here, and then server will have a private key, and then the server can decrypt the data from this private key, and it will get the symmetric key of the user. So all the communications going forward can be taken care by this symmetric key. So let's say if we had that hacker in between, okay. So hacker get hold of this data, okay. So it has an encrypted symmetric key and it has the public key of the server. What can they do? They would need a private key, the server's private key, to decrypt this data. So hacker cannot really decrypt this data. Hacker cannot sniff this data, and they can only read the encrypted data, which is of no use to them as it was encrypted with public key. So they can just encrypt the data and they cannot read or decrypt the data. So this data will be of no use to them. And that is why this communication will be secured. Okay, so our communication looks secure now, but there are still ways through which hacker can intercept this communication and get the required details. So let's say when you were doing a GET request on the server, so this could not be the actual user. Let's say a hacker created a phishing email or something like a dummy website which looks exactly like your bank's website. So you actually provided the GET request to the hacker's website instead of your original website, and then hacker act a user on your behalf, and then it sends the GET request to the server. Now, when the server will send the public key, it will send it to the hacker, because according to the server, your hacker is the user, right? It will intercept that request. Now, this hacker got hold of your server's public key. Okay, this hacker got hold of your server's public key, and now it will send the key back to the user as well. That's not an issue, but then hacker can encrypt the data. Like we earlier had a user symmetric key, now there could be a similar key with hacker. Let's call it hacker symmetric key, right? So hacker can now encrypt the entire data with its own symmetric key, right? And when it goes to the server will decrypt the data and it will send the request to the hacker. It will be able to set the communication with the hacker, right? And you will be compromised. To avoid all this, what happens is over here, server did not identify the hacker, and user did not identify the response that it is getting from the server. So let's see another example over here. Okay. So now, what if there was a way through which we can identify if we are getting the key from the right server, right? So when we did the GET request to the server over here, server responds back with the public key. See over here. So server responds back with the public key. But we are not sure whether this is the public key of server or hacker is acting as a proxy for the server, right? So what if there was a way to validate this, whether this is actually from the server or not? So that's why instead of public and private key, we are using certificates, right? So now instead of this will be a certificate. So certificate, when user receive the certificate, they can validate, browsers can validate that whether this certificate was issued to the domain itself or not, right? So for example, like this is my web browser. So if you go over here, my web browser did the check on behalf of me. And if you go to this icon over here, it says connection is secure, right? And when you click on that, it will say connection is secure and certificate is valid, right? And you can open it to see the certification details. So you can get the common name that certificate was issued to this domain for this organization, and here is the certificate public key as well. Here is the certificate, fingerprints, and issued on, expiry on, and so much other details, right? So now we know that this certificate is valid. There is no hacker in between. And then now we can use the certificate to encrypt our symmetric key and send it over to the server. So now connection will be secure, and now this connection will be used HTTPS protocol. Now this will be a secured hypertext transfer protocol connection, right? So that is why this connection is called SSL TLS, and it is over HTTPS. Now, how would server actually do that? So again, server creates a certificate signing request. Okay, so I'm just gonna add it over here. So it creates a CSR, it creates a certificate signing request, and this request has then to be issued and signed by a certificate authority, right? So there is a certificate authority, it's called CA, and there are many certificate authorities. So we have Symantec, we have DigiCert, we have a few others, right? So for now, just let's take the example of these two. So the server will send a certificate signing request. Okay, so here is our certificate signing request generated by the server, and this request then sent to certificate authority, and then CA actually what it does, it actually validates your request. I'm going to add it over here. It validates your request, it validates your domain, it checks the authentication, and it will make sure that you own the domain, you are the owner of that domain, right? And once it validates, it actually signs the request. Okay, the certificate, it's been signed, and then it will send the certificate to the server, right? So it'll again have a public and private key. Let's just call it public certificate. Okay, and there'll be a private certificate, right? So this private certificate will retain by the server, and this public certificate will be added to the user's browser, right? Okay, so this public certificate will be added to the browser. So every browser will have the public certificate, and it will do the, that's how it is doing the validation, like certificate is valid, and because you have the public certificate, and then it will accept that request from the server itself and then provide the response back. So that's your public certificate on the browser, and that's your private. But this is for the public domains. So the public domains that are available over the internet. There are some domains that are within your intranet. Like let's say if you work for a company, you have some internal websites, your website that is only accessible by your employees within the organization. So for that, you actually don't use the public CA. You use something called as a custom CA, or custom certificate signing authority, or custom certificate authority, that are hosted within your organization, and that is responsible for issuing and signing your certificates, right? So that's how TLS SSL works. In the next video, this is quite a confusing topic, so I've tried my best to explain it, but try to go through the video again, try to take some notes, try to build some diagrams by yourself, and then you will understand like how it actually works. The main part over here is how we actually send the let me show you that diagram. Okay, so the main part is this, how we actually send the user symmetric key to the server. If you understand that part, then it will be easier. So our main goal is to send this symmetric key from user to the server securely, right? And we can do that by encrypting this with the server's public key, and only server private key will be able to decrypt it. So even if there was a hacker in between, he cannot do anything with that. So the main part is this. If you understand this, you would understand how TLS SSL works. After that, just replace the public and private key with the certificates, and there is a certificate authority in between who's responsible for taking care of your certificate signing, and make sure that your domain is valid, your certificate is valid, and you are actually who you say you are. It does that authentication for you, right? So yeah, that's about this video. I'm sure this video was helpful. In the next video, we'll be looking into certificates specifically in Kubernetes, how it works, how do we create the certificate signing request, and we'll go from there. So I hope this video was valuable. If you find it, please try to complete the comments and like target so that I can publish the next video in the next 24 hours or as soon as the target is completed. And feel free to share this to your friends, colleagues who can take this advantage of this learning opportunity. And there is no exercise for this video in the GitHub repo because there is actually nothing to do the hands-on. This is specifically to make you understand how actually it works. And if you understood this, it's well and good. You can try to create some diagrams, some blogs around it, and share your progress with me over LinkedIn or Twitter. And I would gladly provide my feedback on that. So the idea is, like, these concepts are available everywhere, so you can learn from everywhere. The idea is, if you were able to understand that in a simple language or not. If you were, then try to explain that in a blog, in a GitHub repo with the help of diagrams and so on. So yeah, that's it. I will see you soon. Thank you so much, and I hope you have a good day.